Okay, these notes are Geometry 12.4. This lesson is for angle measures and segment lengths. The objective today, students will be able to find the measure of angles performed by chords, secants, and tangents. Remember, a chord has endpoints on the circle. Secants have cross the circle at 2 points but extend outside the circle, and tangents come in contact with the circle at 1 point, and that's that point of tangency. Then students will also find the length of segments associated with circles. Okay, and what are those segments are inside the circle or outside the circle? We'll find out what those things are. Now, we got our objective up top, essentially essential understanding. Angles formed by intersecting lines. Angles formed by intersecting lines have special relationship to the related arcs formed when the lines intersect at a circle. Okay, so we have a secant, not just a blind guy with bad English skills, but a secant is a line that intersects a circle at 2 points. So this is a secant, it's intersecting my circle at 2 points, and a secant continues outside the circle, whether in both directions or in one direction. Okay, line AB is a secant, ray AB is a secant, and and segment AB is also a secant segment. And segment AB is this right here, okay? Coming through here, a secant is on the circle in 2 spots and continues outside the circle. And it could be a chord, a ray, or a line. So that's a secant. Now, the measures of an angle formed by 2 lines that intersect inside the circle. Now, 2 lines that intersect inside the circle, or it could be 2 chords that intersect inside the circle. Okay, we can talk about lines or chords that intersect inside the circles, half the sum of the arcs that are intercepted. So this is one of the arcs and this is the other arc. It's important to keep in mind that this point of intersection does not include the center. Because if it did include the center, X and Y would be exactly the same size. Because they are not the same size, it does not include the center, and therefore we are looking at this average, 1/2 X plus Y. It's an average value, and I'm not sure why I just wrote that because it's right there above there, but you got to keep in mind, for instance, if this were 50 degrees and this is 30 degrees, I would take 50 for X plus 30 for Y, add them together and divide by 2. 80 divided by 2 is 40 degrees. So that would be a 40-degree value of angle 1. And because this is also vertical, this would be 40 degrees, and this arrow area would be 140 because it's be 180 minus that 40 value. So keep that in mind, that relationship that's going on there. So now let's check these out. Oh, another theorem for angle value. Now, I suppose before we get moving on, this is all about the vertex being inside the circle. As soon as the vertex of the angle gets outside, as soon as the vertex is outside the circle, we're looking at, let me get this, theorem 12.4. Now, vertex is outside the circle, okay? The measure of an angle formed by 2 lines that intersect outside of circles, half the difference. So I take and find the difference of the measure of the intercepted arcs, but I want to make sure you understand which things I'm talking about. This really is the measure of angle 1 is equal to half the difference of big arc minus little arc. And people go, what do you mean by little arc, Bloom? Big minus little, and then I divide by 2. And big is the red. You notice that big is the red here? So big is the red, so maybe I should have written big arc like this. And then I would talk about the small little arc is the blue, this blue arc, and that's my little arc. Okay, so keep that in mind. That's my little arc. So it's big arc minus little arc divided by 2. And that's the angle outside the circle. So my angle is outside the circle. And it could be 2 secants. This is the secant-secant relationship, this first one. So I got secant, secant. You know, they're both secants. I got a tangent and a secant, or I have 2 tangents. I got a tangent, tangent. Now we've done the tangent before already, and it's nothing big, but when we come to that particular one, I will talk about how we did it before, but this big arc minus little arc will also work. So I've got an example problem for A. The A is talking about the 1213, so this is example A. And the B, this is 1214, this is example B. So keep in mind which one I'm giving you an example on as we go through. Now, here I'm looking at an angle measure. In letter A, I have two chords crossing, and they create an arc that is intercepted. Okay, I've got a 46 and 90. I will add those two arcs together because it's x plus y. I will add the 46 and I will add the 90 to each other, and I'll have 1/2 of 136, which is 68 degrees. So I took 136, divided it by 2, and came up with 68. All right, so remember, x is 68 degrees. Now, I could ask what this y is. And I'm concerned that you know that they're supplementary. So in this case, 180 minus that 68 would give me my value of y. And if I so chose to put it in the problem this way, and I would subtract and find that it was 112 degrees. So that would be my y value. If I wanted you to find it, it would have been an easy next step. Okay, now in B, it's my big arc minus little arc with a tangent secant combination. This is my tangent line, this is my secant line, and I have a big arc, which is 95. I have no idea what that little arc is. Let's call it X. So I'm going to take and set this up. I've got my angle, this angle is 20 degrees. So that is going to be my first setup. So this is 20 degrees. And I got 95 minus Z. I shouldn't even said X. It's minus Z. So let's get that backed up a little bit here. Let me back it up a little bit. Okay, there we go. And we have, remember, 95 minus Z, and I've got my secant there, will give me my Z, and I know that this is a 20-degree angle on the outside. So I've got that going, and I'm going to multiply by 2 on both sides. I freaked people out there, and all I'm doing here is multiplying by 2 to clear my fraction. That becomes 1, this becomes 40, and now I subtract 95 from both sides, and I get negative 55 equals negative Z, and then I divide by -1 or multiply by -1 and get 55 Z. Now, here's the important part of this. Check, because big arc minus little arc divided by 2 should equal 20. So 95 minus 55 is 40, divided by 2 is 20, totally going to work. Okay, now, those are the two methods we're using. And remember that big arc minus little arc is true for secant, secant, tangent, secant, or tangent, tangent. So let's try them out. Let's see how we do on these. Your opportunity to apply them. See if you get it. Turn me off, give them a try, and then move on. Okay, welcome back. Okay, there's a couple ways of looking at number 1A. When I look at number 1A, we've done this problem before. If I sit there and go, hey, you know something? If that's the center, and these are tangents, and they are tangents, this is 90 degrees and so is that. Okay, so this 110, this arc measure that is 110 is the central angle 110. Okay, and consequently, this is 110, this is 70, and so that's totally going to be working. So I'm set there, and I know that there is 360 minus 110 left. Okay, so I can use that to my advantage to know that that's the case. So I've got 360 going on here. So 360 minus 110 should give me a 250. Okay, ooh, I already showed that. Okay, good for me. But now, let's talk about it according to big arc minus little arc. Okay, if I were to look at this big arc minus little arc, W minus 110 divided by 2 times a half is equal to 70. So multiply by 2 on both sides. 140 is equal to W minus 110. Adding 110 is 250 is equal to W. Either way I do this, I get the right answer, but this is because it's tangent-tangent. I can do this. Only in a tangent-tangent can I get away with this, the way I just did that. Okay? So now let's go after this next one in B. I have an angle Y outside the circle. I have big arc 110, little arc is 30. So I'm looking at this and I've got the measurement outside the circle. I'm going to find their difference. So big arc is 110 and little arc is 30. I subtract those. Okay, and I get myself an 80, and I divide that by 2, and I get that's 40. Keep in mind what is 40. Y is 40. That's my measure of angle 1. Remember, this is my formula, and really my measure of angle 1 is Y at this case. So Y is 40 degrees. My last one is two chords crossing in a circle with a degree measure. Okay, so what I'm saying here, I'm going to take that 35, and really I should show you the equation I'm using. I've got the measure of angle 1, which is this equation inside, because this is what we've seen before, okay, is x plus y. So this is x, this is playing as y, and now I'm able to find the average of the two angles. X plus 30 divided by 2 is equal to 35. At this point, I'm going to multiply by 2 on both sides, okay? And when I do that, I know 70 is equal to x plus 30. I'm going to subtract 30 from both sides and have 40 equal x. So I know for sure 40 is x. And if I add 40 and 30, I get 70. Divide by 2, I get 35. So it works. And it's going to work out real nice. Now, finding an arc measure. This one looks really hard and nasty. A satellite in geostationary orbit above the Earth's equator has viewing angle of Earth formed by the two tangents to the equator. Okay, so it has a viewing angle of Earth. It has two tangents. Oh, and I can't emphasize the importance of this being two tangents, because we've done this problem before, and actually I gave you kind of a inkling of what this problem would be already. Whatever this arc is, it is the same as this central angle, okay? Because the central angle and the arc it intercepts is the same each time. We did this before. This is a four-sided figure that has 360 degrees, and this is 90 degrees, and this is 90 degrees. So this angle and this angle here are 180 degrees together. So really, I know that the arc that they're interested in, my arc here that we want to find, this arc, we'll call that A. Okay, my arc A is really A plus 17.5 is equal to 180 degrees. So the viewing angle that's about 17.5, we're supposed to, what is the measure? The measure of the arc of the Earth that is viewed from the satellite. And that's this arc measure here with that same angle. So I'm subtracting and I'm finding that 180 minus 17.5 is 162.5. So A is 162.5 degrees right there. Now, I have some folks going, Bloom, but you know, it has big minus little. I wouldn't even figure it out that way. That's the way I would do it. Okay, so this is the end of part 1 for the chapter 4 notes, and we are going to go on and get after those other parts in a little bit. Okay, this is part 2 for chapter 4 notes. Chapter 12.4 notes. This is theorem 1215. For a given point and circle, the product of the lengths of two segments from the point to the circle is constant along any line through the point and circle. Boy, that looks confusing. So let's just talk about it this way. And we've got this going on. I'm going to put this here Ooh, that's locked, so we're going to unlock that real quick so we can get this up here. All right, so here's the deal. There is a relationship between the chord crossed here and the chord that crosses here and how they break up the pieces. If I break up the pieces for my first chord, A and B, I can multiply them together, and then I break up the pieces for my second chord, C and D, and I multiply those together. The product of the parts of those two chords, it's got to stay with the same, are always equal inside a circle, okay? So that's case one. The product of the two chord segments are equal. Now, case 2 and 3 are very similar, okay? And I want to talk about that. This is a secant line. This also is a secant line. And if you would like, you can totally do this way, okay? And look at this as W plus X. Well, W plus X is the entire length of the blue secant. And Y plus Z. Y plus Z is the entire length of the secant. W happens to be the outside portion of that first secant, and Y happens to be the outside portion of the second secant. So here's what it really boils down to. I take the outside length times the entire length, and that's equal to the outside length times the entire length. Okay, that not only works for the one in case 2, but it also works in case 3. The outside length in the red, see this is a secant, it's the outside length times the entire length, Y plus Z, and that is the outside length times the entire length. And just to make sure you see it, Y plus Z is the entire length, and Y is the outside length alone. So that outside length times the entire length is equal to the outside length times the entire length. Now, in part 3, the outside length and the entire length is T. Because it's a tangent, there is no length inside the circle. The entire length and the outside length are the same value. That's why it's T squared. Okay, so you can do it and look at it with this relationship, no problem, but this is the outside length times the entire length, okay? And this is the outside length times the entire length. So for both of these, in case 2 and 3, that's what we're looking at. The outside portion times the entire length of each is equal to each other. So how do we use this when we're looking at this? Now again, I'm not looking for angles. It looks like an angle, but I have segment values. I have this segment value, which is 6, and then I've got the whole length, which is 14. This segment value, which is 7, and then the whole length, which is 7 plus y. So the outside times the entire length. 6 is the outside, the entire length is 14. 7 is the outside, the entire length is 7 plus y. After I do that setup, I'm in algebra land. Okay, so I've got 84 is equal to 49 plus 7y. I subtract 49 and find out that 35 is equal to 7y, and now I divide by 7 and find that my answer is y is equal to 5. Now, outside times entire length is my mantra. That's the thing I'm mumbling to myself. This outside times the entire length is 8 times 24, and this outside times the entire length is the same, so it's equal to z squared. Z squared is equal to 8 times 24. After I make that the statement, that setup, I'm in algebra land. Z squared is equal to 192. I take the square root and I get 13.86. Now they don't tell me to round to a particular value, and that's why I went to the 100th. Now we're going to have this opportunity to practice this, so go ahead and get her done. Find the value of each variable, shut me off, and then turn it on, then shut me off, and then turn it on and see how you're doing. Okay, so in this one, the hardest thing is finding out which number goes with which segment. This is 3 and 7. This is 6.5 in M. Okay, so I'm going to go 6.5 times M. I got A times B is equal to C times C, so I got 6.5 times M is equal to 3 times 7. So now I got 6.5 M is equal to 21. I divide and find out that 3.23 is my M value. Okay, and I'm just gonna double check that on my calculator and make sure that I'm going along and going, all right, I got 21 divided by 6.5 and I've got 3.23. And the next one, and problem 2, hopefully you've shut me off and I'm coming back. Remember, it's outside times the entire length. That's the deal. So on this one, I'm gonna have 14 times 34. On this one, I'm gonna have 16 times 16 plus X. Okay, so that's what I've set up, but it's outside times the entire length, 14 times 34, and 16 plus X times 16. And now I just distribute, and I'm busy getting things done. So now I've got 220 equals 16, and I've got 13.75 as X. My last one, remember, outside times entire length. The outside on the top, X is the tangent, so it's outside and the entire length is the same value, so that's gonna be X squared. And then I've got the outside times, which is 6, times the entire length, which is 13.5. Okay, so I've got the outside, 6 times 13.5, and then the entire length times the outside is X squared on the other one, and that's my setup, and I multiply, and I got 81 equals X squared, so X is 9. And I should be able to know that that's the case of my value. Now, keeping in mind, that was problem 3 here. If you have questions and you are watching the video and you weren't in class live, make sure you talk to your instructor and make sure you understand how the setups are working. Now on this next one, this is a really down and dirty, do you get it? Okay, there's a lot of stuff going on. You have to keep your eyes on the prize. So make sure you understand what's going on at each step. Sometimes you got to do one before the other. Okay, so there's a lot of things going on. Give it a try and then turn it back on and see how it goes. Okay, welcome back. We have a couple things going on here. And okay, so this first one, I'm going to start out and I'm going to work with 10 going along here in X and 9 and 6. Why? Because they are just the easiest ones that I saw. I'm just working with side lengths, segment lengths. So X times 10 is equal to 9 times 6. That's my first one. X times 10 is equal to 9 times 6. And just to make sure you know what I'm doing here, I'm going to make those blue. Okay, so X times 10, 9 times 6 is my chord-chord relationship. And I go 5.4 because 6 times 9 is 54, and I divide that by 10, and that's where 5.4 comes from. The next thing, since I'm doing sides, okay, okay, I'm going to go in here, I'm going to talk about the outside times the entire length. Z squared is equal to 6 times 6 plus 9. Remember, 6, 6, and 9, that's what I'm using. 6, 6, and 9 is 21 times 6. So 21 times 6 is equal to Z squared. Okay, 21 times 6. So remember, it's the outside times the entire length. And the entire length is 21 plus 9, or 12 plus 9, which is 21. And so I've got that set up here. I've got 126 on the right, and now I'm going to take the square root of both sides and have 11.2 is the value for Z. Now remember, what I've done so far is just about the side lengths. Okay, so I've done side lengths. Now let's go after angle measures. And you all are going, well, what angle measures? So I've got this angle measure here, okay, because these are intercepting this arc, and this is intercepting this arc. So I'm going to go after the average of 85 and 45. Okay, 85 plus 45 divided by 2 is going to give me my 65-degree angle there for my angle where the chords cross. Okay, now we've gone through the information for 12.4 in its entirety, part 1 and part 2, depending how it's broken down. Make sure you look to see, you've got the summary here, you've got an objective, defined measures of angles formed by chords, secants, and tangents. Write a couple sentences about something that you learned today about the learning objective and rate yourself on how to do it from 0 to 4. I hope things are going well, and again, Two things. One, if you have questions about today's stuff, make sure you talk to your instructor. Two, I cannot emphasize the importance of rereading your notes on a daily basis to keep everything straight. There's a lot of vocabulary. Once you know the vocabulary, it's adding, subtracting, multiplying, and dividing. Have yourself a great day.